Okay, based upon traffic flow, the types of highways based upon traffic flow, there were two: interrupted, uninterrupted. Okay. Then we talked about traffic data. Traffic data can also be divided into two types, right? Two types of traffic data, traffic parameters. Microscopic and macroscopic. Okay. And microscopic is small, one or two vehicles. Macroscopic is group of vehicles. Okay. Within each category, we will discuss three. Within each category, we will discuss three. Okay. We started with macro. Okay. Okay. Yeah, not asking. We started with volume. Okay. And volume can also be called flow or rate of flow. How do we define volume? Number of what? Vehicles per day or per hour. Can it be less than 1 hour? Yes, and then we call it flow. Okay. If you take the flow and convert it to 1 hour, rate of flow or flow rate. Okay. Then we discussed 4 types of daily volumes. Okay. Okay, we discussed 4 types of daily volumes. These were ADT, AWT, ADT, and AWT. Okay, ADT means average of whole year, all days. AWT means average of whole year, only weekdays. Only weekdays. ADT means average of all days, but which A is missing? Less than 1 year. So the A of annual is missing here, right? It was ADT. I took the annual out. It becomes ADT. Okay. And the last one is AWT. Average of weekdays and less than 1 year. Okay. Now, the reason why I need the slides is you see a table on the next slide, slide number 9. Can you see the table?
Yes.
Okay. This table shows you 12 months of data. For each month, you see the name of the month. You see how many weekdays are in each month. Now, weekdays means which days? Sunday to Thursday. Okay, Sunday to Thursday. Now, how do I know this? I have to open the calendar and count. Every month doesn't have same number of weekdays, and every year the same month will not have the same number of weekdays. Okay, so you have to go and open the calendar and count. Okay, so like they are showing, January has 22. Last January may have 23 or 24 or 21. Okay, so you have to count. Next column, number of days. You can memorize it, no problem. Or you have the knuckle rule, right? Huh? You know. Everybody knows. You know or not? What? Number of days and the month. You can count from here, right? Okay. I'm asking because in one exam I didn't give the number of days in the month, and people were asking how many days are in the month. So then I made a mistake. I said, okay, assume 30. So they assume 30 in all of them. Like even February was 30. Okay. So then you have fourth column, column number 4. Total traffic in each month. Total. So total for January 31 days. For February total of 28 days. Okay. Last column, column number 5. Traffic of weekdays. So from the total they subtracted what? Weekends. Okay. They are just showing us the total, but in their record they have the weekends and the weekdays. So they took out the weekends. We have column number 5. Clear? Okay. Now for this data they are saying calculate these 4 things. Okay. They start with AADT. What did I say about AADT? Average of full year. Okay, and for all days. Okay, so what is the traffic of the whole year? It's written. Total is given, right?
Yes.
Total for each column is given. So what is the total of whole year? Right? Total of column number 4. Okay, over total days, which is can it be anything other than 365? It can be. Can it be anything other than 365 number of days? No? No? Sure. Sure? Sure? It will be 366. So 365 or 366 depending on February. Okay, how much is this? Yeah, how much is total the AD?
14917.
14917 meters per day. Sorry? Yeah, usually the decimal for volume we round it off. Okay, so you can write how much is it? 0.8. You can make it 8, no problem. Okay, but we don't write decimals in volume. Okay, volume or flow, we don't write the decimals. Okay, next one, AWT. AWT, total of what? Weekdays. Where is it? Yeah, total of column 5, right?
Yes.
Okay. Over total of
260.
weekdays. Okay, 260.
And some 9934. 9934, but it still be 9935.
990. Okay, this 260, the total of column 2, will it always be this? It will not. So how do I know? You have to count. Okay? There is no formula here, there is no fixed number here. You have to go open the calendar and count. You count it for each month and you add them. Got it? Huh? Okay. Then ADT. ADT is for less than 1 year, right? Now you look at the data. Less than 1 year for how many days?
60, 50.
No. Less than 1 year from the data. How much time period can I take for less than 1 year? 1 month, because the data is given for each month. Okay? When somebody says, okay, now do for ADT. ADT means less than 1 year. less than 1 year. In this case, it can be for each month because the data is given for each month. Okay. So for example, if you want ADT for January, ADT I take total, right? Total. So total traffic for January is 425,000. Number of days in January is 31. Okay, so how much?
One three eight 06. Something. 428.
How much?
1370.
137. Sir, okay. 710. One three seven 13710. Okay. Okay. AWT again for January. Tuesday upon how many days? Weekdays in January? 20. How much? 9455. Okay, clear? Any problem? Can you do it for the rest of the months? Okay. Now, you see AADT, going back to AADT. It's for the whole year, right? Okay. And then you calculate AWT as well. So AADT is higher, AWT is lower. What does it tell you about this place or about this highway? When you take the overall AADT, it is higher. When you only take weekdays, it becomes lower. That means what? Weekend. The weekend traffic is higher. On this location, the weekend traffic is higher. So maybe it's a location where people go on weekend. You know about these places. Don't tell me. Okay? Another thing. Now, if you calculate ADT and AWT for each month, then you can see the variation in traffic in different seasons as well, right? Maybe it's more in summer, maybe it's more in winter. So looking at the traffic, you can tell things about the place. What type of place is it? What type of highway is it? Got it? Okay. What about the travel of the people? What time they want to go to this place and so on. Clear? Okay. Any questions? Okay. Moving on. Then we have hourly volumes. Okay. Now hourly volume is used for design. When you want to design something, a highway, a bridge, a signal, the client says, okay, give me the design. You'll ask for what? You'll ask for hourly volume. Volume per hour. Okay. Now what was the use of daily volume? What was the use of daily volume? Hourly volume is for design. Daily volume is for planning. Okay, I give the example of metro. When they were planning metro, They are planning for how much daily volume it will have. Okay. Now you do planning for future, right? And design for past. Design also for future. Future, right? Near, far, but future, right? Now the problem is the client has future daily volume, and you want what? Future hourly. Okay. So I need some conversion. I need to convert. I'm designing for hourly, but I have daily. So hourly will come from daily. Got it? Yeah. Okay. So we need an equation to convert the daily into hourly, and the equation is given there on slide number 10. Okay. The equation is given for DDHV. DDHV stands for Directional Design Hourly Volume. Okay. So again, the first word is what? Directional. Meaning what? It's for one direction. Daily volume was total of both directions. Hourly volume is for one direction. Okay. The next letter is what? Design, because I'm using it for design. And the next two letters are hourly volume. So we are using what? Hourly volume. Clear? Okay. Now what is the equation? A into D into K. Right? What is A? A is daily volume. We already said, right? We are converting daily to hourly. So A is what? Daily. So to calculate DDHV, you need daily. A. Next thing is D, which is the percentage of traffic which comes in the peak direction. Daily was total, right? So is this total divided equally in both directions? Direction 1 will have 50%, direction 2 will have 50%. Not always. So D, and so which direction you will design for? The higher one, the peak one. Okay. So D is the percentage in that direction. Percentage of traffic in that direction, which has a higher volume. Okay. I will come to it. Then K. K is the percentage of traffic in the peak hour. So I'm designing for hourly volume, right? And all hours don't have the same volume. So I will design for the peak hour, the hour which has what? The highest, the peak. Okay. So how much traffic in percentage is in the peak hour? That is K. Okay. So you need daily volume, you need D and K. Percentage of traffic in one direction and percentage of traffic in the peak hour. Okay. Now D and K. The best thing to find out D and K is collect your own data for both directions for each hour and calculate your own D and K. The best thing. Okay. But we are not the best people. So we'll go to the next slide. Okay. The next slide gives you what? A table. Okay. The table has ranges of D and K. But these ranges are for different types of areas and highways. Okay. We have one range for rural area. We have one range for suburban area and two for urban areas. Now rural means area with low population, a village. Urban means area with very high population. Okay. What is suburban? Suburban is near the boundary. Suburban is near the boundary of urban. If you are outside the boundary, it's rural. If you are in the center of the boundary, it's urban. If you are near the boundary, it is suburban. Clear? Okay. Now, for urban, you have two types of ranges, right? One for radial route, the other one for circumferential route. The radial comes from radius. Okay? And radius means what? Radius means half of diameter. It goes from where to where?
From center to the boundary.
From center to the boundary. So a highway which goes from center to the boundary, we call it radial. A highway which goes from center to the boundary, center of the area to the boundary, we call it what? Radial. Okay. And circumferential comes from circumference. Circumference. And circumference is around the center. Circumference is around the center. Okay. So if you have the center of the area, a highway is connecting center to the boundary. You call it radial. A highway is going around the center. You call it circumferential. Clear? Okay. Now, we'll come to the next slide. You will see a question. A rural highway is to be designed for 20 years. For these 20 years, the ADT is given. Okay. And they are saying use the data of that table. Which table? 5.2 is that table with K and D values. Okay. To calculate the range of DDHVs. So they need the range of DDHV. Okay. Why the range? Because if you go to the rural area, go back to the table. For rural area, there is a range of K and the range of D. Okay. So for one area, you can calculate a range of design volume. Okay. So for example, if you are doing it for rural area and you are calculating the minimum value. Okay. So minimum value will be, you will use the minimum for the range. Okay. So ADT is 30,000 multiplied by what is the minimum of K? And what is the minimum of D? Okay. So when you multiply 30,000 with minimum of K and minimum of D, you will get minimum of DDH. And you can do the same thing for maximum. So same volume, now multiply by maximum of K and maximum of D. How much is minimum? 2925. Now what are the units? Vehicles per hour, because hourly volume. Another one? 6,000. Okay, so for the same area, for the same highway, you can have a range depending upon your K and D factors. Okay, now if you look at the values, one is almost 3,000, the other one is 6,000. So it's double, right? I just change the values in the same range and I get a very big difference in the design volume. Okay. Now somebody may say, I will take the, which one? Average. You can take average, no problem. Okay. But average means that you have a chance of underestimating. You may have underestimated the value, right? Or you may be taking a lower value when the actual value could be higher. There's a chance, right? You take an average, there's a chance for that. Okay. The other option is what? Take the maximum. If you take the maximum, okay, then there is no chance of underestimation, but the cost will be higher. You will be designing a bigger highway, right? You need more cost. Okay? No? Okay. So, the point is not which value you are taking. You should know if you take a specific value, what will happen in the end. Any value, you can justify any value. You can say, okay, I will take an average, no problem. Okay, you can defend it, no problem. You can take maximum, no problem. You can even take minimum as well, no problem. Because it's in the same area. So until and unless you have some other data, your client comes and says, no, I have the actual data, forget about these values. Use this. Until and unless you have this, you took any value from the range, you got any answer, you can. But you should know what will happen in the end. Okay? Now, if you go back to the equation of DDHV, in the equation of DDHV, I used 30,000 here, right? In this example, I used 30,000. Okay? 30,000 as what? $30,000 was AADT, right? Okay. Is there AADT in this equation? The equation has what? A. The equation says A into D into K. The equation doesn't say AADT. It says A. So any A. It can be AADT, can be AWT, it can be ADT, it can be AWT. Any daily volume. Any daily volume can be taken. Okay? Depends upon what? Depends upon, first of all, what do you have? They gave me ADT, right? So I'll use ADT. Okay? If they gave me ADT, I will use ADT. Okay? So that's why in the equation they did not fix it. Usually we prefer ADT. ADT is considered more suitable. But it can be any other daily volume, no problem. Got it? Okay. Now, yeah, okay. So selection of daily volume depends upon the data which is given to you. In the last example, the first example which we did, where we calculated ADT and AADT and AWT and everything, the data was given for the whole year, right? So I can calculate all these four things, ADT, AWT, ADT, AWT. I can calculate because the data is enough. If somebody gave me data of 1 month and they told me calculate AADT, you cannot, right? Somebody gave me total of the whole year only, total. We use what? 5445, whatever the total was. Somebody just gave me this value. Now he says calculate ADT of January. I cannot. Okay? Clear or not? No? Huh? If total traffic of the whole year is given, nothing else, you can divide by 365 and get ADT, right? Can you use the same value to calculate ADT of January? No, because for that you need total traffic of January. Okay? So what you are calculating, first of all, depends upon what data is given. Clear? So ADT and AWT cannot be for the whole year. And similarly, AADT and AAWT cannot be for less than 1 year. Okay? You cannot interchange them. Okay, I have to calculate AADT, but the data is 1 month, I will call it AADT. No. You cannot do it. They are asking for ADT, but I have the total of the whole year, I will call it ADT. No. Okay? You can call it something else, but not ADT. Okay? Now, going to slide number 13 now. Slide number 13 says sub-hourly volume and rates of flow. Sub-hourly volume, we called it flow yesterday. Sub-hourly volume means what? Flow. flow is taken for how much time? Less than 1 hour. Okay, and rate of flow converted to 1 hour. Flow converted to 1 hour. Okay, I use daily volume for planning. Then I convert daily volume to hourly volume for design. And even for management of traffic, I use hourly volume. If somebody says, okay, traffic is too much, change signal timing, put a stop sign, change the speed limit, again I will use hourly volume. So why do I need flow? Why do I need sub-hourly volume? Now, sub-hourly volume is important because if you don't consider it, then this can affect your design. How? You gave me DDHP, right? In this example, the last example, DDHP, right? The maximum DDHP was 6,000. 6,000 per hour. How many per minute? 6,000 per hour. How many per minute? How much? 100 per minute, right? So if somebody goes on the field and start counting vehicles every minute, will he count exactly 100 every minute? Some minutes will have more, some will have less. So there's a fluctuation, right? There's a fluctuation, okay? Now if you don't consider this fluctuation, it will ruin your design. How? Go to the next slide. For this we have to look at the example. Without example you cannot understand this, okay? It's magic. Somebody takes traffic from 5 to 6 p.m. okay? And between 5 to 6 p.m. they are counting variation every 15 minutes, right? The count is given every 15 minutes. Okay. Now, at the end, they have given the total as well, 4,200, right? Okay. What do you call this 4,200? Is it volume? Is it flow? Is it rate of flow? Is it daily volume, hourly volume? What is it? It will be 4,200. It will be volume. Which volume? Hourly volume. It's for 1 hour, right? 4,200 is the total of 1 hour, right? Okay. 4,200 is the total of an hour. So we call it hourly volume. What about these values which are given for 15 minutes? Column 2, 1,000, 1,100. What do we call it? Flow, because they are for 15 minutes. And then you look at the second column. Each value is converted to per hour. So we call it what? Rate of flow. Got it? So in this table you see all three things. Hourly volume, flow and rate of flow. The last one. This 4,000 and 4,400, these ones. You converted the 1,000 to 1 hour, right? 1,000 was for 15 minutes. You converted to 1 hour, it became 4,000. 4,000 is rate of flow. Okay, it's written there. Okay. Now, let's say this highway is designed for volume of 4,200. When the people designed this highway, they designed for a volume of 4,200. How much is the actual volume now? The actual volume is 4,200. The design is 4,200 and the actual is also. Should there be any problem? No. Okay, this is what you say. Now, if they designed it for 4,200 in 1 hour, how many vehicles can this highway pass in 15 minutes? 4,200 in 1 hour. How many in 15 minutes? How many in 15 minutes? 1,050. Okay. So if the design volume was 4,200 per hour, then it means it is 1,050 per 15 minutes. Got it? Clear? Any question? Okay, which is what is written on the next slide. Go to the next slide. You? There's problem. Yeah, I know. Okay, so you look in this slide. Column number 3 is showing this 1050, which you just calculated. This is the design flow for 15 minutes. The design hourly volume was 4200, which means design flow is for 1050, which is written in column number 3 here. Okay, and column number 2 shows the actual flow, which we saw in the last slide. When you add up column number 2, you get how much? Huh? When you add column number 2, you get, we just did it, right? They just showed you in the previous slide.
Okay.
Actual flow. You add actual flows, you get how much? 4200. And you add column number 3, you get how much? Come on, you are doing it. 4200. The actual is 4200, and the design is also 4200, right? Okay. Now, so it looks fine. Okay, but now see what will happen. Each 15 minutes. First 15 minutes. Compare between column 2 and 3. Which one is higher? Column 3 is higher. Column 3 is higher. So I have more design and actual is less. No problem. Okay. Look at next 15 minutes. Which one is higher?
Second.
Actual is higher.
Yes.
Design is less. How much higher? 50. So the highway can only pass 1050 vehicles. The actual is 1100. These 50 vehicles cannot pass. The extra 50 vehicles cannot pass. Okay, so 1050 pass, 50 are left. Keep it in mind. Okay, next 15 minutes. Actual is 1200, right? 1200, and the design is 1050. Again, there are some extra vehicles, right? How many extra vehicles? 150. And then we have 50 from previous as well. So total 200. Okay, 1050 will pass, 150 from these will remain, and 50 already there, total 200. Okay, come to the last 15 minutes. How many vehicles are coming? 900. 900. It is less than capacity. This one is less than capacity. But what is the problem? I already have 200 from the previous 30 minutes, right? So this is not 900. This is 900 plus 200. Total 1100. My capacity is how much? 1050. Okay. So 1050 will pass out of 1100. How many left? You can see in the last column. 50 is still left. Okay. Now what did I say? 4200 is the capacity, and the actual is also 4200. So from where did these 50 vehicles come? Are these extra vehicles? No, they are part of the 4200 which I designed, right? Which I took into my design. Okay. So how many vehicles actually passed? 4200 minus 50, because these 50 have not passed. They are still stuck on the highway. See what happened? Okay, like I said, it's magic. Capacity 4200, actual 4200, 50 is still left. Why? Because you did not consider how the traffic is moving up and down between 15 minutes interval. Okay, so now you can see the evidence that it will affect your design. If you don't consider it, your design is not achieved. Your design was 4200, right? And you achieved how much? 4150. Okay, so if you do not consider the fluctuation of flow, the fluctuation of sub-hourly volume, then you cannot achieve the full design. Got it? Clear? Okay, if all these values were 1000, 1000, 1000, then you will not have any problem. If all these values were 900, 900, 900, you will not have these problems. If all the values were 1100, 1100, you will have more than 50. You will have more than 50 in the end. Okay? So just by not considering the fluctuation, even if you consider the total number correctly, accurately, it will not solve the problem. Yeah. Okay. So for that we use a factor, and that we will discuss next time. Any questions? Clear?